Okay, just wait, I am starting. Okay, so next topics, how to solve the linear time varying discrete time step equations. Okay, so the topic is solution of linear time varying discrete time state equations. Okay, so consider the following. Consider the following linear time varying discrete time state equation and output equation. We have previously seen these two equations. You know that x of k plus 1, which is equal to, gk xk plus hk uk. This is equation number 1. And output equation you see, that is y of k. This is ck xk plus dk. This is the output equation. So previous solutions, previous expressions, we have to express these input and output equations. Now, so we have to apply the recursion method of equation 1. So we have to express that is x of h plus 1. This is equal to g of h into x of h plus h of h u of h. This is the first term, h plus 1. Then next one, h plus 2, and so on. This process is continuing, you know that. So what have to do? So this is the g of h plus 1 into x of h plus 1 plus h of h plus 1 u of h plus 1. Okay. This is the basically procedure. Now we have to change this equation. This is we have to write same equation, that is g of h plus 1 into gh xh plus g of h plus 1 into h of small h qh plus h of h plus 1 u of these two terms we have to also change this in this part. So now this part is continuing, you know that. Now let us define the state transition matrix that is also called the state transition matrix, which is also called fundamental matrix. Okay, so please remember these terms also. Fundamental matrix. Next page. For the system define the equation that is equation number 1 as we have to express this equation psi of kh. Okay, so it is a unique matrix satisfying the condition. Yeah. So now we have to express this equation, that is psi of k plus 1 into h. Let's put k plus 1 comma h. This is equal to g of k psi k comma h, and this is psi of h. This is equal to I, capital I, where you know k is equal to here h plus 2, sorry, it's h plus 1, then h plus 2 dot dot dot. Okay, so it can be seen that the state transition matrix that is psi kh is given by the equation that is psi k of h. This is equal to g k minus 1 g k minus 2 dot dot g of h, where k is also greater than of h. Okay, so this is the equation number 2. Now, using, is it clear all of you up to this part? This is psi kh, the solution of equation 1 becomes, क्या था equation 1? So this is the equation 1, you know that. So x of k, this is psi k comma h into xh plus a summation of j is equal to h k minus 1 summation of k minus j, sorry, k comma j plus 1 into hj, where a is also greater than the, this is equation number 3 and this is a 4. Okay, now so in the previous equations you see in the right hand side, it is contribution of the initial state of the xh and current state of the xk of the second one. So I am giving the last equations. So in these equations, this is the right hand side. So here the initial state of the x of h, okay, to the current state, that is the x of k, okay, and here k is also greater than the h also. So the basically input of the terms, basically here input of the terms. So the contribution of the input, that is uh plus 1 dot dot u of k minus 1. Okay, so now equation, previous equations, just wait, that is equation 4 and equation 3 we have to consider for here. So equation 4 can be verified easily referring to the equation to the equation 3, we have, that is psi of k plus 1 h, this is equal to gk into gk minus 1 dot dot g of h. So now we have to express these equations. This is equal to gk into psi of k comma h. This is equation number 5. Okay, so if we substitute equation, that is equation 5, into, that is x of k plus 1, this is equal to psi of k plus 1, k plus 1 comma h, h into x of h plus a summation of j is equal to h to highest power k psi of k plus 1 into j plus 1 into h of j u of, okay. So this is the required equations we have to express from the figure. So next, that is, sorry, x of k plus 1, x of k plus 1, this is equal to, you know, gk psi of k comma h xh plus a summation of G is equal to h to the power k minus 1 maximum power psi of k plus 1 into j plus 1 into h j plus summation of psi of k plus 1 into hk. Okay, so this is the substitute equation of the equation 5, where the value of psi range is k plus 1, another is h. So now we have to write the equations finally, that is also x of k plus 1, this is equal to gk within third bracket psi k comma h into xh plus summation of j of h k minus 1 into summation of psi kj plus 1 hj uj plus hk uj. So now we have to express this. This is the final equations. Gk xk plus hk uk. That is x of k plus 1. Okay. Is it okay, all of you? And another part we have to express here, psi inverse of AH. We have to express that is psi of H2. And you know that this is the G of k minus 1 into G of k minus 2 dot dot G of H to the power inverse. Another we have to express that is G inverse H, G inverse H plus 1 dot dot G inverse k minus 1. So this is the another equation. I think equation number 6. So coming to the point, so the state transition matrix according to our linear time varying and linear time invariant system. So we have to express the particular rules we have to follow. So I am written here summary on psi h. So a summary on the state transition matrix psi kh gives the following. So number 1, you have to remember the psi of k comma k, this is equal to I. Number 2, this is another term, psi of k comma h, this is equal to, you have to express here g of k minus 1, into g of k minus 2 dot dot up to the g of h. But here you know that where k is greater than of the h. Okay. Number third condition, if the inverse of sine kh is exists, then psi inverse kh, this is equal to sine of h. Okay. And another condition you have to remember, if gk is non-singular for all k values considered, then psi of k comma I, this is psi kj into psi ji for any I comma j comma. Another, for gk is singular for any value of k, then I'm written next page. This is sine of k comma I. This is equal to sine of kj into psi into ji for when k is greater than of j and also greater than of j is greater than of I. So this is the basically 4 points of summary you have to follow for the state transition matrix. Okay, is it okay, all of you?
Yes, sir.
Okay, next, this is the last terms, last topics. This module, that is a pulse transfer function matrix. So second module we have to cover the pulse transfer functions. Okay, so how it is calculated, pulse transfer functions. So now this pulse transfer functions you have to express the state space representations method. Okay, so the topic is pulse transfer function matrix. So the single input and single output discrete time system, it may be modeled by a pulse transfer function. Okay, SISO. That is single input and single output. You know that single input, single output. So this single input and single output are discrete time system, that is SISO, are discrete time system may be modeled by a pulse transfer function. So pulse transfer function. So in this pulse transfer functions, we have to also concept a multiple input and multiple output discrete time system. You know that because you know the k is also changes, that is 1, 2, 3, 4. So these are basically different inputs you have to given, that is multiple input, and it is given also multiple output. Okay, so now these state space representations, the state space representation of the nth order linear time invariant discrete time system with R inputs and M outputs can be given by this is previous equations x of a plus 1 which is equal to g of xk plus h of uk. This is equation number 1, and output equation that is yk is equal to c of xk into plus g of uk. Equation number 2. So here I'm giving from the next page where xk is an invector, uk is an r vector, yk is an invector, and capital G is an n into n matrix, that is row and column also same to same. Another one we have to express here, H is an n into r, n into r matrix, and C is expressed here, that is also C is n into n matrix. Okay. and D is basically M into R. So now taking the Z transform of equation 1 and 2, that is previous equation 1 and 2, these two equation 1 and equation 2, we get that is a Z transform of xz minus z of x0, this is equal to z of xz plus h of z, and output, that is y of z, this is equal to c of z plus d of z. You know that. Next, and previously we have to express this pulse transfer function, that is also called the assumption of the zero initial condition. So when the zero initial conditions, we have to previously express the equations, you know, that is xz is equal to zi minus g inverse h into uz, and output of the equation, that is yz is equal to c of zi minus g inverse h plus g into uz. Previously we have to explain these equations, so we have to express this equation here, that is if z, this is the basically if z into uz, where I am written here, where if z is equal to c of zi minus g inverse to h plus, this is equation number 5. So here this fj is called the pulse transfer function matrix, okay, and it is an M into R matrix. Okay. It is basically M into R matrix. So this pulse transfer function, that is the f of z, it characterizes the input output dynamics of the given discrete time complex system. So now the inverse, that means since the inverse of matrix, that is zi minus g, can be written as zi minus g inverse, which is equal to adjacent of zi minus g, that is mod of zi minus. Okay, so the pulse transfer function matrix, that is f of j, can be written as okay, everyone write your own name and roll number in the chat box also. Pranav is present. Pranav? Pranav is not present. Plus Nitya say plus Nitya.
Yes, sir. Yes, sir.
Pranav, yes, Pranav, you take a screenshot again.
Yes, sir.
Okay, so now the pulse transfer functions, that is a matrix fz, we have to express finally, that is z is equal to c adjacent of the zi minus g into each by mod of zi minus g plus. So this is the basically equations for the pulse transfer functions of matrix. Okay. Now clearly here the poles of f of j are the zeros of, that is zi minus, sorry, g mod of zi minus g. This is equal to 0. That means we have expressed here zi minus g mod of zi minus g. This is equal to 0. So, or the number of terms, n number of terms, so we expressed here z to the power n plus a1 z to the power n minus 1. You see that this pulse transfer function in the previous module, that is a1, a2, and here z to the power n minus 1 and minus 2 plus dot dot plus. Before of the last term, that is a n minus 1 into j plus a. So where the coefficient of ai, this is ai, depends on the element of g. Okay, so this is the basically pulse transfer matrix functions of the state space equations. So ऐसे भी question आ सकते हैं how to calculate the pulse transfer functions using the state space analysis. Okay, तभी आपको ये वाला draw करना पड़ेगा. Okay, is it okay all of you? So your module 3,
Yes, sir.
your module 3, that is the pulse transfer, sorry, module 3 name is state space analysis. So I think those topics are available in your syllabus. Every topics we have to cover in our classes. So please everyone go through the books. There are different types of problems are available. So please practice. Okay, then the clear idea you have to achieve from the module. Next class we have to start it in either physically, that is module 4. Okay, देखते हैं कब से क्लास स्टार्ट हो रहा है. आई थिंक नेक्स्ट वीक से हो जाएगा, ऐसे कुछ लग रहा है.